Today I'm going to talk about a new feature that we introduced on Android O, which is called Android Autofill Framework. So the idea here is I'm going to give an idea of why we added this new feature, how it works, and more importantly, what you can do to make sure that your apps work well with this framework. So prior to O, Android has the Android ecosystem has a class of apps called password managers. These are very useful apps because they allow the users to easily log in on other apps without having to remember their username and password and having to type. Because sometimes it can be a hassle to bring up the keyboard and type on a small screen. So these password managers, they've been there for a while. They've been working even before Oreo. But the problem is that we never offered a proper way for them to do their jobs. By we, I mean the Android platform. So they have to rely on some hacks to get their job done. For example, they often offer a custom keyboard where the user can type and they can see what's going on with the keyboard, or they have their own browser, or even worse, they force the users to set themselves as an accessibility service for the device. So these hacks are kind of bad, in particular being accessibility service, because when you say, hey, this app is my accessibility service, you're pretty much grant access to everything that happens on your display to that application. So this is bad for performance because there's a lot of events that are generated, and many of these events are irrelevant for autofill. And it's also bad for security and privacy because you're hoping that these applications are only using this power to autofill your credentials, but they could be monitoring what mail you sent, who you call, etc. I've been working with some of these password managers, and I trust they don't abuse the API in that manner. In fact, the main reason that we've been developing this API is because they keep asking us, hey, we use the accessibility API, and the accessibility API is too slow or too complicated to use for our use case. Can you folks improve the accessibility API for our needs? And our answer has been, no, we cannot help you. We cannot improve the APIs for your needs because you're not the legitimate use case for the accessibility API. The accessibility API is meant to help people that has disability, for example, people has vision problems. So they have this service that they have to scan everything that's happening on the screen and somehow notify that user. So in that case, the performance is not a big deal and they really need access to everything. So basically, the accessibility is not the right choice for them, but we could not blame them because they really needed them. That's the best they could do. So rather than improve the way they hack the system, we decided to offer a new solution that's designed to help them do their job well and in a performatic way. So basically, on Android O, we introduced this new framework called Android Autofill Framework, and this was a new API that was designed from ground up for autofill purpose. So because of these design decisions, it offers much better performance than the accessibility API, because now we are only generating events that are necessary for autofill, and they're customized for autofill and only sent on the right time, not all the time. And it's also more secure, and the privacy is better as well, because now when you say, hey, this password manager is my autofill service, you know that the only power that you're granting to them is to be an autofill service, not an accessibility service where they look at everything that happens on your screen. And even though this is a new API, it was designed from, we leveraged existing concepts from other APIs, like the accessibility API itself and the Assist API, which is used by Google now and the Google Assistant. So we leverage a lot of experience from the Android framework teams and other teams to write a good API for this job. So one nice thing about this new API, a new framework, is that it's an open API. So basically, we provide some API. If you want to implement an autofill service, there's a set of API that you need to implement, and it's open to everybody. Like you could go there and create your own autofill service. Usually, there's going to be a default service with your OEM. For example, if you have a Pixel or a Nexus device from Google, the default provider will be autofill with Google. But you could go to the Play Store and download another password manager and set it as your accessibility service. So when we designed this API, we worked closely with the 4 biggest password managers, 1Password, Keeper, Dashlane, and LastPass. So we got a lot of feedback from them, and a lot of the features that we added was based on their requests. But after we launched this API and the SDK was available, other apps, they just implemented and published themselves to the Play Store. For example, recently I found the Impasse and Safe in Cloud, they all implemented the API. There's also this multi-data set autofill service, which is the sample that we provide. So you could download that sample, compile, make our changes, and install if you want to play around with the API. Now, one key decision that we have to make when we designed this API was that this API should work out of the box with existing apps. That means we shouldn't require app developers to explicitly change their APIs to support the framework. And there was a good reason for that. If we require people to adopt the API, it will take time. So every time we launch a new API, it might take months or many releases for developers to adapt to the new API, and sometimes they're not even aware of the API. And as such, the password managers, they wouldn't switch from the accessibility to autofill, because accessibility is available in 100% of apps, and then autofill maybe would be available in like 20, 25%. So we make this, there was a conscious decision, and usually that's fine, it works out of the box for most apps, but sometimes it doesn't. And that's one of the main topics of this presentation. I want to explain why it works out of the box and why sometimes it doesn't. And in order to understand that, we can take a look on how autofill works. What is the workflow that happens when we show an autofill UI from a user? This particular slide, I kind of borrow from our I/O 17 presentation, Google I/O. So I'm going to use a Twitter as an example. So this, the workflow, there is three processes involved. In one hand, you have your application, which is the application that's going to be autofilled. On the other hand, you have an autofill service, which is the application that has the user data, like a password manager or autofill Google. And then in between them, we have the Android runtime system, which is a mediator required for performance, security, and privacy reasons. So the whole workflow starts when the user focuses on autofillable fields on the app. So in this case, when the user launches Twitter and focus go to the username, we are going to be automatically triggering the autofill workflow. And when that happens, the autofill infrastructure running on the app process, they create a customized version of the view structure that is optimized for autofill and send that view structure to the Android system. The Android system, they want to strip out some personal data from the user from this view structure and then send a sanitized version of the view structure to the autofill service. Now, here comes the interesting part. The autofill service will look on this view structure and will try to find which views could be autofilled. For example, is there a username and password or phone number here? So if they found this autofillable structure, now they're going to look on the user data for that particular app. It's okay, there is a username and password here, so there is a match. Then they will create a new data structure that we call dataset and send that dataset to the Android system. Now, at this point, the Android system has all the information they need to autofill the app. But one of the security mechanisms that we introduced in this API was that we never injected data from the autofill service to the app or vice versa without the user consent. So rather than autofilling the app directly, we display a security UI on the Android system process that's overlaying over the application. And then we show all the options sent by the user, by the service. In this case, there was just one data set. So now, only when the user selected that data set, then we send the data set back to the app process, and the autofill infrastructure will automatically fill the views on the app. So this is the whole workflow in a nutshell. It's a little bit more complicated than that, but basically that's what happens behind the scenes. And usually this happens pretty fast. The whole UI might show up in like 100 milliseconds or sometimes even less. Depends on how good the service has to get data cached, etc. So this is a very nice workflow. It works well most of the time. There is only a catch. It only works if the autofill service could figure out where to put the user data. So most of the time, generally, for example, on this demo that we did on Google I/O, that was before we launched the API. So autofill with Google had the heuristics. They knew how to figure out what was the username and password from the Twitter app without the Twitter app developers change their app, so it worked fine. But sometimes it might not work. Generally speaking, these autofill services or password managers, they have pretty good heuristics and they can figure out how to autofill your view. But you shouldn't rely on their heuristics because sometimes things could go wrong. In particular, there are two bad scenarios that could happen from the user point of view. In one case, imagine that you're using an application. You know that your password manager has credentials for that app, but the password manager doesn't find out how to autofill. Now you, as a user, have to go there and manually type the username and password again. And this is kind of annoying because that's the kind of hassle you're trying to avoid by using a password manager. So this is one problem that's kind of bad. The other one is the other way around. Sometimes the autofill service thinks that something could be autofilled, but it doesn't make sense. For example, when I was developing the API last year, once I want to send an SMS to my friend using Hangouts, and I got a suggestion with my phone number. That kind of doesn't make sense. Like, why would I send an SMS to myself, right? I'm kind of insane, but not to that level. So it would be nice if the autofill service didn't try to autofill that. So the good news is, even if you don't want to support, you're not aware of the autofill framework, but if you are, it's relatively simple to support to make sure that service does your job properly. And you do that by the easiest way is to annotate your XML with some autofill tags. So basically, the key idea here is that you shouldn't rely on the autofill service, which is something you don't control, to offer a good user experience for your app. It's better if you tell the service how they should autofill your app. And you can do that by helping them answering three kinds of questions. One is, what is the meaning of the autofillable views? For example, which views as username, which views as password or credit card expiration date. So rather than hope that they would figure out what the views means, it's better if you tell them beforehand. Similarly, you should tell them which views should not be autofilled. For example, this is a Hangouts SMS editor. Don't try to autofill telephone number here. Even if you identify that that field is a telephone number, it shouldn't be autofilling because that's something the user is going to be typing. And the third thing you should do that's very important when you have when the user might have credentials for a website as well, you should tell the system how to map your website to your app. Just to give an example of Twitter, let's say I'm using LastPass or some password manager, and I haven't used them on Android yet, but they have a plugin on Chrome or Firefox where I log in on Twitter once, and they associate my credentials with the twitter.com website. Now I'm installing this autofill password manager on my phone, and I'm using Twitter. Somehow they have to know that twitter.com is associated with the Twitter app. Maybe for the top apps, they might have a whitelist, they might have a QA team or someone who's doing the association. But for a smaller app, they would know for sure. So you need to tell them how to do this mapping, and we'll see how over the next slides. So basically, let's take a better look on how we answer these three questions, which is hopefully they cover most of the apps, and then we'll see some more advanced cases. So for the first question, what's the meaning of autofillable views? You can answer that by tagging your XML view, the layout XML with the Android Autofill hints tag. So basically, this is you can pass an arbitrary number of strings, and this string could be any form, free form. So you basically are telling the service, hey, here's the meaning, here's the metadata for my app. So usually you're going to be using something like username or password, but you could use something as bizarre as my dog's favorite color last year in San Francisco during the drought. The problem is if you use something like that, it's going to be useless because the service wouldn't know what it means. So to avoid this kind of miscommunication problem, we offer constants for the most common values on view.java. So if you go to view.java and look for the autofill hints underscore something, these are values that the service should understand. So you would be, and they cover the majority of the cases. For the other problem, if you need to tell the service, hey, don't bother autofill this view, you can use the Android importer for autofill tags and say no. So basically, you are telling, this import for autofill is not sent to the service itself, but is used by the Android system. When Android system sees a view that's not import for autofill, they exclude that view from the data that's sent to the service. But pretty much the service wouldn't even know there is such a view on the view structure. And finally, to map your web credentials to the Android app, there is a protocol called Digital Asset Links. That's something Google introduced a few years ago. Some of you may be familiar with that technology already. That's the same technology that allows your the Android system to automatically open URL links from your app when you register your app to handle that URL. So basically, it's the same protocol. It's slightly different because now, rather than asking them to handle URLs, you're also asking them to handle login credentials. We'll see some examples soon. By speaking of example, let's go to some. I would like to show some demos here today, but I'm using my Chromebook. I don't have a phone here, long story short. I'm not running emulator or anything. So I'm just going to do some screenshots and screen code snippets. Hopefully that will be enough. So the login screen is the typical use case where a password manager is useful. So let's say I have my login screen that has a username, password, and CAPTCHA edited fields. So the username and password, these are the fields that I want the Autofill service to file for me, while the CAPTCHA, that's something that I need to manually type because I'm proving to the app that I'm a human, or a tree in this case, and not a robot. So let's see how we can tell annotator XML to convey that information. Let's start with the passwords. In this case, I have a password field, and I'm adding this Android Autofill hints equals password. Again, this password string, that's a predefined value that you can look on view.java and use. Eventually, we're going to have support from Lint, from Android Studio. They will maybe able to autofill that for us as well. And for the text field, this is slightly more complicated. I mean, not complicated, but let's say my app allows either username or email address. I don't know, when I create my app, I don't know which of these two pieces of information the service has for a given user. So it's better to send here, say, hey, you can autofill this with either username or email address. Then at runtime, the service will figure out which of these values are available for the user and file properly. Finally, for the CAPTCHA, I say, hey, this is not important for autofill, so our mark is important for autofill equals no. In that case, the service doesn't even know there is a CAPTCHA field, and they're not going to send the incorrect data to fill that view. Also, since the Android system doesn't send the data to the service at all when the view is not important for autofill, that also improves the performance, because now there is one less event, one less object that is created, and this might sound like a small performance improvement, but remember, we're running on a mobile device and every little optimization counts. In fact, there might be cases where your whole activity doesn't make sense to be autofilled. For example, the Hangouts SMS editor that I mentioned was one scenario, or a spreadsheet editor is another case. So let's say I have a spreadsheet like that on Google Docs. It might have hundreds of views, and it doesn't make sense to try to autofill these views because these are values that the user will be dynamically entering. So you could mark this whole activity as not autofillable or not important for autofill, and you do that by annotating the root structure of your view hierarchy with the import for autofill equals no exclude descendants. Basically, we are telling the system that not only the view is not important for autofill, but every other view inside that view are not important as well. Just keep in mind that when you set something as not important for autofill, you're not really disabling autofill on that view. What not important for autofill means, actually there are two meanings. One is we're not going to be triggering the automatically autofill workflow when we focus on that view. Remember early on when I showed the workflow, the whole workflow starts when a user tapped on username on the Twitter app. So if that view was marked as not important for autofill, or the whole activity was marked as not important for autofill, we wouldn't trigger autofill in that case, which wouldn't be useful on our previous example of the spreadsheet editor. And also it means that if somehow the autofill workflow was triggered by another view, for example, on the login screen, like the username triggered autofill, but the view itself, like the CAPTCHA view, was marked as not important, so that view would not be sent to the service. The catch here is that it only applies to the automatic workflow. Even if you mark a view as not important for autofill, the user can still force an autofill request. Typically, they can long press the text field and select autofill from the menu. In that case, not only we send the whole view, not only we trigger autofill, but we send the whole hierarchy, even those markers not important for autofill. This feature in particular, there was some feedback we get from the autofill service, because they said sometimes they cannot figure out how to autofill one app. So they need to force a way for the user to request autofill on a particular field, and they could have a custom UI when the user can say, hey, this field is my username, this field is my password. So this is a kind of an advanced feature for more like a plan B when things doesn't work. Just going back to our spreadsheet example, if I long press the enter text area here, there would be an autofill option. And actually I was pointing here, but my finger is not a mouse. So I can click autofill here, and then I will trigger autofill. Finally, also, since we are, at this point, since we're explicitly telling the service, hey, my login screen has these two fields, for the one has the username and the other one has the password, then pretty much everything else on that screen is not important for autofill. For example, I don't need to send a text view containing my labels, because there is not going to do anything with that label. If I was not, let's go back to the Twitter example before they annotate their views for autofill. So let's say you don't do anything for your view, like you're not annotating your view for autofill, then it's possible that the autofill service needs to see the labels to figure out which one. Let's say you have a label saying username and then the edit text, and a label saying password and an edit text. So the autofill service might need to look on the label to figure out that the next field is a username or the next field is a password. But in this case, when I'm explicitly telling you, hey, this is my username, this is the password, they don't need to use the label. So you could annotate the labels as not important for autofill. And again, you could be optimizing the process even more because now we are only sending the 2 views that are important. Everything else we throw away. So we are optimizing how many data flows from the app to the system and to the service and vice versa. Finally, the third thing you could do is map your web to your app. Basically use these digital set links, which is a way to say, hey, basically you're doing statements to tell, I have this domain, and these are the apps that are legitimately pertain to my domain. So this is important things to do in the cases where you have a website. And if you have typically you might have an app and you have a website as well where the user can log in on the website. So it's nice to set this link so the autofill service will know how to securely fill your application with the data from your domain. And you set the digital asset links. There is 2 steps. One, you need to set up a JSON file on your website. There's a well-known path where you create a JSON, where you create a relationship between a permission and the target. In the case, the target is your Android app and has the certificate here, so they can verify that your app is the real one trying to request something. And the permission is the common get login credentials. That's the one that is slightly different. If you've been using digital asset links for URL handling, the permissions is another one, is a handle all URLs or something like that, but you can just add a new line. Then you also need to add a quick manifest, metadata on your manifest to make on your app itself. So these are the 3 main ways, like for majority of cases, by just doing these 3 small tips, like saying what it should be autofill with autofill hints, saying what should not be autofill with import for autofill equals no, and setting the digital set links, that should cover the majority of the apps. But there's some apps where they need to go 1 step further and define what is the autofill behavior of their custom views. So when I say custom views, I mean if they create their own views, like their own edit text or their own spinner, or maybe if they are extending the existing class from the SDK framework, from the Android framework SDK, you might need to do something to support autofill. You might also need to notify the Android system when something happens to your view, like when the value is changed or the visibility changed or focus was gained or lost. Most of the time, you don't have to worry about this because the main view classes take care for you, but we will see an example where you should it. So the idea here is on the view class itself is like a blank canvas. So the view doesn't know if that view is going to be a container for other views, or it's going to be a text field, or if it's going to be a combo box, a radio button. So the view doesn't know how to tell the autofill service that it could be autofilled, and it doesn't know how to autofill itself when the autofill service sends some data to us. So in order to tell the view how to do that job, you need to override the get autofill type and get autofill values to provide that metadata. So basically, autofill type is going to be, we have some predefined types like a text, date, or list. And then we have this autofill value, which is how we represent the value that can be autofilled. And we have factory methods to create those depending on the type. And then on the other way around, you have to implement a method called autofill, which is the one that the Android system calls you when they get a value from the system and ask the view to autofill. There might be some cases where you have to set the autofill options as well. I'll show that on an example that will be clear. For now, let's focus on the autofill type, value, and autofill. So before we look on how custom view should work, I'm not looking at my slides. And there might be some cases also where you need to notify the Android system when the view changed, and you go through the autofill manager. So now I'm right. So before we take a look on a real custom view, let's take a look on views from the Android SDK. So the most common view that can be autofilled is a text view or edited text. And in this case, the type of the text is a text, right? Something the user is typing is going to be a text. So if you look on the text view from the Android SDK, they are implementing the get autofill type and say, hey, my type is autofill text, and get autofill value, they're going to create a factory from the autofill value to say, hey, here's the text, and create an autofill value for that text. Similarly, when they get an autofill value from the system, they will extract the text value and set their internal text with that value. So this is the most common case. Now let's see a slightly different case, which is a spinner. So a spinner, it's a UI where the user doesn't type a text, but rather they select a value from a list of values. So in that case, the autofill type is a list, and the autofill value now is going to be an index like that says here is the selected item on my list. And similarly, when the autofill service sends a value to you, they will be sending the index, and then you need to update your data structure directly internally with that value. Now, the trickiest part is, let's say this spinner represents a credit card expiration year. So how would the service knows if the first value is 2016, 2017, or 2018? So you need to provide some metadata that tells the service, here are the values that I can autofill this list, and we do that through the autofill options property. Unfortunately, we didn't add a get autofill options on the view itself, so you need to override its own provided autofill structure and set the autofill options for that structure. In this case, so you see the spinner is setting the autofill options here from the structure that is received. And in the case of the spinner, they also getting the options from the adapter, so you wouldn't have to extend the spinner directly, but you need to somehow set these autofill options on the adapter. That being said, let's see a real sample now, which is coincidentally the credit card with expiration date. So this is going to be the most common case. I predict that people might need to customize the behavior of the existing views. So basically, normally there are two ways you can represent a credit card expiration date. You could have individual UIs for month and year, or you could have one simple field for both of them. For example, you could have a text view where when the user clicks that view, you launch a date picker, and then when the user selects the date picker, you update the view. So similarly, for the autofill, from the autofill point of view, this expiration date could be just one field or two fields for month and year. So let's see how a combination of these four scenarios using examples. So the simplest example is when you're using the UI, you're using the spinner directly. So I have on my view here, I have two fields for month and year, and they are normal spinners. So the difference here now, I have a normal on my active layout XML, I have these two spinners, and I'm notating them with the credit card expiration month and credit card expiration year. So basically, these are values predefined on view.java, and the autofill service will know that these are credit card expiration month and year, respectively. Now, this is the only hint you need to do, but the trick here is you need to tell the service what the meaning of these values, right? Which values are going to be on the spinner. So let's say for the month, you're statically generating the months, reading some resource from an XML file. In that case, the array adapter class will automatically set the autofill options that are sent to the service, because they know that this data is sanitized. They know that this data is coming from the resources, so it doesn't have a personal information, that data. Now, if you're dynamically creating a spinner, for example, I want to dynamically define what years I'm sending on the expiration year. I'm creating I still have an array adapter, but I'm explicitly creating the values that I'm setting on this adapter. Now, in this case, I need to also override the get autofill options from the adapter, because since I'm dynamically creating, that information would be stripped out. It would not be sent to the service. So in order to do that, I need to create a custom adapter, like I'm extending the array adapter and overriding this get autofill options method, returning my years that I create dynamically. Now, this is kind of a hassle. It would be much easier if the array adapter had an option to set the autofill options. And I realized that kind of late in the game, so we added this API on OMR1. So if you're using MR1, I could simply call set autofill options on the adapter. But if I'm using less than MR1, then I need to do that trick and extend the adapter. Now let's take the other example, which is expiration date as a compound view. So from the UI point of view, this is exactly the same UI. I have two spinners. The difference is now I have these two spinners. They are located on another view, like a layout or frame layout. But from the autofill point of view, that's the view that should be autofilled. Like my view is handling the state of the child view. So in this case, on my XML layout, I'm going to have just one view, which is my custom credit card view. And now the type is not a month or year, but it's credit card expiration date, because I'm telling the service you have to provide the whole date here, the month and year at the same time. Now, my view is extended frame layout, and frame layout is one of those views where they have no idea how to autofill. Like by default, they don't do anything for autofilling because the user doesn't autofill a container, right? They autofill individual fields. But in this case now, I have a special case where my frame layout itself is an editable or autofillable view. So the first thing I'm going to do, I'm going to explicitly set the import for autofill as yes, but yes exclude descendants, which means I'm import for autofill, but my child are not, so don't bother trying to send this child information to the service. And now, here's one case where I need to notify the service when the value changes, because I need to tell, since from the autofill framework, this is my view that should be autofilled. I need to tell the system when my view changed. So I can create a on-item selected listener for my child spinners, and then when these items are changed, then I'm notify the system that my main view changed as well. So I'm gonna get the autofill manager, say the value changed from my class, from this class. I also need to tell the system what's the metadata, what kind of view this autofill type this view represents, and how to autofill it. So in this case, my autofill type is a date, and I have a factor for date that basically I'm going to be keeping an internal calendar on my spinners, on my activity, and then I'll get the date from that calendar. And when the user changes the spinner, I omitted this code, but when the spinner is changed, we update the calendar as well. And then the autofill method is the other way around. I'll get the calendar. I'll set the values from my calendar from this value passed by the service, and then I will update my spinners with the values from this new calendar, with the month and year. Our final example is the date picker based approach. In this approach, my expiration date is a text view, but the user this is not an editable text view. The user is not going to change that value, but rather when the user tap the expiration date, we will launch a date picker where they can select the month and year, and then we'll send that value back to the text view. So here's the date picker itself. So now again, I just have one view, like I'm creating my custom view, and it's autofill hints is credit card expiration date. The type and the autofill value and autofill is similar. So my autofill type is type, my autofill value is use the factor method. And now when I receive an autofill, same thing here. I need to convert that to my internal calendar. And now I'm going to update my text, like the read-only text on my text view with the month/year, or ideally you should use a date format, but the guys got the idea, folks. Sorry, guys. Now, these are the typical, most common cases where you might need to optimize your apps or custom views for autofill. Now, there is another another callback that we provide that is important, which is the autofill UI callbacks. Basically, this callback could be used when your app has your own pop-up, your autocomplete views. So the idea is, if you're going to be showing, you don't want to show both the system autofill, the autofill UI from the system should not overlap with yours. So basically, the idea is, when the autofill framework is going to draw the UI, they will tell you, hey, the UI is going to be shown. And when the UI is going to be hidden or when the UI is not available, we notify as well. So you can change your app accordingly. Just to showing what happens if you don't do that, you might end up in a situation like this. The user type to type something, we're going to be getting a UI from your pop-up window. So to avoid this scenario, basically you create a new autofill callback. You register that callback on resume and you unregister on pause. And then the callback, you have to see, okay, this is the events that were generated by the autofill framework. So when the UI is shown, then I'm going to be hiding my UI by disabling my adapter. In this case, I'm using autocomplete text view. And similarly, when the UI is hidden or if the UI is not available because the service doesn't have a data set, then I will show my dropdown. So if you just follow this simple trick, you're avoiding showing both UIs at the same time. There is also a more sophisticated scenario where your app has what we call virtual views. So for example, let's say I have an application like this one here, where I'm literally drawing my username and password. So from the Android point of view, there is just one view on this activity, but this view, I'm literally calling the canvas and drawing my username and password. So if you have a situation like that, let's say you're using OpenGL, some OpenGL library that has a user input, or your browser rendering HTML internally. So you might need to do a little bit more work. Basically, you need to implement some APIs that tell the system what's the autofill state of this your child. So I'm not going to go through much details about this particular case, because this is a more extreme scenario. It's not really common. But one thing that is, okay, sorry. I'm just going to show again the screenshot of existing app, and I'll tell how if you guys folks want to run this later. But the idea is I'm drawing everything myself here, but since I'm implementing the proper APIs, when I tap my username, I notify the system that the focus went to the username, and I create all the view structure, everything. So I'm getting the data from the username, from the system, and when I select something, then I'm implementing the autofill and other methods, and I'm autofilling my view. So this virtual view mechanism is necessary for things like web view. So web view is one kind of critical component on the Android system, and it's kind of hard to implement this sort of API as well, because the problem with web view, when you add a web view on your app, from the main layout point of view, from the view hierarchy, there's just one web view. The HTML that you are loading is actually rendering another process. There is a Chrome process that rendering that layout, and they are drawing that on the web view. So we need a way from the web view to notify the system of what's the autofill state from the app. So that's why we developed we designed this virtual views hierarchy API. If you're using web view, you don't have to worry about this API, because that's automatically handled by web view itself. The only thing you have to keep in mind is that now, because you don't have directly, but the good news is WebView will take care of that for you. In particular, if you're using the autocomplete tag, in this case, I have my text, my example app where I say, hey, I have a username and password, and autocomplete equals username, and autocomplete equals current password. Note that this current password is slightly different than the password that we define on Vue.java, because this is an autocomplete tag. So you shouldn't worry about using the autofill hints options on your HTML. Just stick to the standard W3C tags, and the service will do the proper conversion. Finally, just keep in mind that when we launched Android O, it came with Chrome version 60, and WebView on Chrome 60 didn't support autofill yet. So you need at least 61. That shouldn't be an issue anymore, because most users, they are either on 61 or 62. But if your WebView is not working, make sure to check what version is running. So these were pretty much all the hints I have on how to prepare your app to use autofill. So now let's say you folks are very excited about this technology, and you're going to go home today, even before lunch, say, okay, I'm going to enable my app for autofill. So you're going to launch Android Studio, add the autofill hints, import for autofill, set your DAO link, etc. Now, how can you tell if your app is really working with autofill? How do you test that you're add the proper support to autofill? So basically, you have two options, or maybe three if you're a more radical person. So the radical option, the hardcore option, say, okay, this is a public API. I'm going to write my own autofill service. I don't think that's doable. If you want to do that, sure, go for it. We will help you. But it's not really a good option, because your business logic is your app. Unless you're a password manager or a browser like Firefox, you don't need to worry about autofilling and being a browser itself, right? So you want to focus on providing the autofill hints to the autofill service, not being an autofill service itself. So that gives us the second option. Why can I use an existing autofill service like autofill Google or LastPass-Lane? Yes, that's a viable option as well. But I wouldn't recommend that option as well, at least not initially, because let's say I'm using autofill with Google, and autofill Google can autofill my app fine. Now, at this point, you don't know if you annotate your views properly, or if Google has a good heuristics to detect how to autofill your app. So that leaves us to the third option, which is using our standard autofill implementation, the one like a reference implementation that we provide in the samples. So this is a very simple implementation where it doesn't have any heuristic at all. It's only going to be looking for important for autofill, for the autofill hints annotation. So if you're not annotating your views with import for autofills, with autofill hints, then autofill is not going to work for your app. Similarly, if you're using WebView and you don't set up your digital assets link properly, you're going to get a toast that says, hey, I cannot autofill your app because I cannot verify that this app belongs to your domain. So this is a good way to start. You could start using this sample app, and then if it works with the sample app, then you know that should work with any other password manager, and then you can try with other ones. So now let's try to do some demo with the autofill service, and I'm actually lying because we don't have time for do a real demo, so I'll show more screenshots. And this is not a screenshot we're going to show, but so this is our autofill service. Basically, it's an open source project that's available on GitHub. There's a reference, if you go to the main autofill documentation, there's a link to this website. And there's a lot of intermediate classes here, but the most important ones are the autofill service itself. And there's also a setting page where you can customize the behavior of the autofill service. For example, you can automatically generate some data sets initially. And also we provide apps as well. There's a lot of apps. All these techniques that we mentioned, how to use a credit card with a spinners, with a date picker, custom views, or virtual view, the login, a callback, all these examples, basically, we have an app for that. So you could download the apps as well and play around to understand how this works, and then you apply to your apps. So that's pretty much what I have to tell. I'm glad actually that we still have like 3 minutes for questions. I thought we would have just one, but 3 is better. So if you guys folks have any questions, you can ask now or mail me or something. Okay, so you're closer, so I'll do you next.
Is there a support library for autofill on older versions?
It doesn't, because all this work, it requires the framework support. Basically, the support library, the idea is when you have support library, that's something that can be done, like you could just go implement your own viewer stuff, right? But in the case of autofill, a lot of this happens on the framework. For example, we have all these UIs drawn by the system process and other stuff. So unfortunately, yes, we couldn't get that from support library.
Is there support for JSR 310 types to avoid time zone issues with the date picker?
I don't think we don't have anything specifically for that, because when you set the date, basically it's just a long, right? So as long as you pass the object, I think we can tell what's the date, the time zone from the device, and then the autofill service will have to create the proper object, but we don't have anything specifically to handle that. There's someone on.
So when you use the autofill, you are filling up the text field. A yellow layer going to be displayed over the text field. Is that a way to or change the color, or even just to not display this?
Yes and no. I mean, changing the color, no, because this is handled by the framework. I think there might be some theme, like you might be able to customize the theme that shows the color. We tried to make it that customizable, but that was really hard because the text field is just one example of views, right? You could have custom views, spinning, and other views. So we decided to draw that color ourselves. Now, if you want to disable that I think it's possible. You could, because the way we know that the view should be changed, the color is, okay, we try to autofill, and we know that the autofill value, the current autofill value is the same autofill value that we passed. So in theory, you could do some manipulations on the autofill methods to trick the system to not realize that it was autofilled. So it's not something that I would recommend doing, and that I don't know the exact way that you can do that. Even if you do that kind of hack, it might not work in the future because we might change how we change that color. But the idea is we want to make sure to the user that it was the data was autofilled, so they know they can look at that and say, okay, that's the data that came from the service. Okay, so I guess we're done. We finished 14 seconds before the 45 minutes limit.